The question is you are given a number n. Find the total count of set bits for all numbers from 1 to n, both inclusive, means first and last number is also included in our count list. For example, if n equals to 4, the number from 0, 1, 2, 3, and 4 will have 5 bits set in its binary form. For numbers from 1 to 4, 1 will be this, 2 will be this, 3 will be having 2 bit sets, and 4 will be having 1 set bits. Therefore, the total set bits will be 5. Similarly, for 17, it will be 35. Now, the expected time complexity for solving this question is big of log n, and auxiliary space will be obviously big of 1 because there is no need of any auxiliary space in this bit manipulation question. Now, for solving this question in extreme brute force, we are gonna take a counter from 1 to n and individually count their set bits by the trick in bit manipulation by AND operation, bitwise AND operation of current number and its previous number, which will give us, which will turn off basically its rightmost bit. It will clear the rightmost bit of its ith value, and we will do it by counting, incrementing count every time, and we'll do it if I is always be greater than 1, and at last we will check if I is equals to 1, we will again increment the count. This is the extreme brute force solution which we could think of. Now coming towards the optimized solution. This solution will be tricky for beginners. So let me explain it with the editorial that Geek for Geeks provides us. The approach is to recognize the pattern. Now you would have noticed by converting of binary to decimal number or decimal to binary number that binary numbers have a pattern in their bits. The last bits will be alternating their bits from 0 to 1, 0 to 1, 0 to 1. So there is pattern observed here. Similarly, for the second last bit, it's 0, 0, 1, 1. Similarly, for third last bit, it's 0, 0, 0, 0, 1, 1, 1, 1, and for so on. Now, a pattern to observe here, to notice here, is that for two numbers, there is only one bit which is set. For the last second bit, there for four numbers, there are two bits set. And we could take advantage of this pattern, right? For this solution, we will increment our n for 1 because we will be including our 0 for our pattern inclusion to set our pattern so that we will achieve our solution. This thing has no effect on set bits because 0 has no 1 bits in its binary form. Now, this is the optimized solution which I could have think of when I first saw the problem that you could might see trouble by saying this. What I basically did is I calculated the how many times this while loop will be running. I will talk about it later while loop. Uh, this is the log value of the end which I'll be receiving and its seal value that I done. We know log value of any number base any number would be divisible will be divided by the log value of base e. So the number of times in times is the log value of n. I have set a counter for incrementing our pound bits. The power is 2, will starting from 2, 4, 8, and so on. Now, while times greater than 0, I'll simply decrement the time, and this is the reason why I have used time here. There are two involvement properties here. First, how many bits are set, and second, the remaining remainder of which my division operator leaves those remaining pattern beside. We need to include those pattern also because it will be included in our answer, final answer. I'll simply divide it with the power of 2 which this current cycle of while loop has, and I'll multiply it with the power. Right shift means multiply, and for the remainder part I'll calculate the remainder. I'll check if the remainder is greater than the my current power divided by 2 value, then I'll need to include the remaining remainders that are left in my pattern, or else I'll simply put 0 and I'll multiply my power by 2 by every cycle and then finally return my count. This is the most simple solution I could think of. uh, GFG tutorial will give you a little complicated solution which you could refer from here. And please comment your doubts for my current session and suggest me any improvements if needed. Thank you.